Hi everyone, today we are going to be looking at periodic functions. So this first slide says, what do you notice, what do you wonder? Okay, so maybe you notice a pattern, maybe you notice some ups and downs. So this is what we're going to be looking at today, and these are called periodic functions. So a periodic function is a function that produces a graph that has a regular repeating pattern over a constant interval, so over the same interval. So some examples of real-world periodic functions. So the sun. So if you look here, the sun has a repeating pattern. Another example are tides. Tides coming in and tides going out. Another example are sound waves, the phases of the moon, etc. So again, a periodic function is a function that produces a graph that has a regular repeating pattern over a constant interval. Okay, so let's take a look at these examples here. So which functions below is or are periodic? So the first one has a repeating pattern of up, down, up, down, up, down. So we could argue yes. The next one, although it kind of looks like it might repeat, the only problem is that we have this one really low minimum and this other minimum that's not quite as low, so it's not exactly the same, so this is not periodic. The next one, we kind of have the exact same pattern, down, flat, down, flat, up, flat. Okay, so yes, this is periodic. Okay, so we're gonna look at some terminology here. So just like when we're working with parabolas, we have this kind of line that we could fold the function in half. So in a parabola, it was the axis of symmetry. In a periodic function, it's called the axis of curve, and it's this horizontal line that cuts our parabola in half down the middle. And that's called the axis of curve, and we abbreviate that AOC. Okay, the next terminology that we're going to look at is called the amplitude. So the amplitude is the length between our axis of curve and either the maximum, so this is called a maximum, or the minimum. So in this case, this is 2 units, and this is 2 units. So the amplitude has to be the same for a periodic function. So the next terminology that we're going to look at is period. So period is the start and the end of one pattern. So basically from one maximum to the other maximum. So whatever this length is the period. So in this case, so this is at 3 and this is at 11. So 11 minus 3 is going to be your period. So 8 units. Okay. We could also look at the period from the minimums to the minimums. This is also 8 units from -1 to 7. We could look from here, if we go what's called a cycle. So this is from 1 to 9, so that's also 8 units. So it doesn't matter where we are on the curve, the period is always the same, and that is 8 units. So the period of the function is the length of one cycle measured along the horizontal axis. Okay, so in this particular example, so if this is a maximum, to the next maximum, there's 1 cycle, there's 2 cycles, and we don't have quite another full cycle. So we basically have 2.5 cycles here. All right, periodic function. So determine the period of this function. Okay, so again, I can look from the maximum to the maximum or to the minimum to the minimum. It doesn't really matter. So this length here between -2 and +2 is 4 units. Okay, again, minimum to minimum, this length is 4 units. Okay. All right, determine the period of the function. So again, I'm going to pick a starting point. I'm going to choose the origin. And then, so 1 cycle here. Okay, so that's a length or a period of 360 degrees, okay? Or I could have figured out from maximum to maximum. So 450 take away 90 is also 360. So there is a formula to calculate the amplitude, and that is the maximum value, subtract the minimum value, and divide that by 2. So in other words, we're taking the maximum. So I don't have any scale on this one, but let's say this was 2, and this was -2. So we would have 2 minus -2 divided by 2 for the amplitude. And that would give us 4/2. So in this case, the amplitude would equal 2 units. Okay, so all right, so we could figure out the amplitude of this one as well. So we actually have a scale here. So 4 and -4. So the amplitude is equal to 4 minus -4 divided by 2, which is 8/2. And that's 4. And we could also just figure it out. So here's my AOC, and I can literally just count boxes here, okay? So if you can't count boxes very easily, then you can make this side calculation over here, but 4 units is the amplitude. Okay, here's another one, slightly different scale. This time we're using radians as our scale. Okay, so the axis of curve this time is at the half mark. So again, I could look at my maximum, look at my minimum. So I have an amplitude 1 minus 0/2, which is equal to 1/2. So 1/2 units. Or again, I could literally just count boxes, okay? So between 1 and 1/2, that's 1/2, or 0.5. Okay, that's 1/2. All right, so in the interest of time, I'm gonna skip this one. Let me see if I have anything else here. Actually, we'll just do this last one here. Okay, so here's my AOC. So the amplitude, I can look at the graph and see that it's 3 units, okay? If you wanna make the calculation, again, amplitude is equal to 1 minus -5/2, which is 6/2 and 3 units. Okay, that's it for today's lesson.